accidentally the recording to say now I split the video in 2 or 3. I don't know exactly what's going on, guys. This is only happening in this class. Other class, no. Okay, then I focus in the quadratic equation. Oh, it's easy by factorization. The combination is 9 and 2. Because 9 times 2 is 18, 9 plus 2 is 11, minus both equal to 0. It's because x is 9 and x is 2. And that's it? No, because you need to check it. Remember, sometimes, not always, but sometimes happen the solutions of this equation not exactly is coincident with the solution of the original equation. Therefore, I need to plug it in into the original equation to verify it's true or not. So checking for 9. I'm checking for 2. Maybe there are no rules. Maybe both are good, or maybe one is good, or maybe no, one is not good, or maybe both are not good. So we have no solution. What I need to check arithmetic is square root 9 plus 7 plus 5 would be 9. So you replace x for 9. Likewise, you replace for 2. 2 plus 7 plus 5 should be 2. In this case, 16. And the square root 16 is 4. And 4 plus 5 is obvious. Okay, yes, it's 9. Solution 9 is okay. Boom. And this is 9. The square root 9 is 3. And 3 plus 5 is not 2. 3 plus 5 is 8. This is completely false. And you discard the solution gets extraneous solution. Therefore, the only solution that we have in this radical equation is 9. Any question? Extremely important. So you forgot to check in, no credit. The checking is important in radical equation. Any question, guys? No?
No.
Okay, super. Let's move on. Question 10. So 10, 11, and 12 is, you know, equations and inequality that contain absolute value. Suppose 10 is equation. Absolute value 5m plus 2 equal 7. Some people, I don't know why, remove this and solve this and believe que the answer. No. You are doing this, you have 0. You need to know that this is equivalent this exactly and this. If you want to connect them by one word, it's or. And you solve and separate 2 equations because you have 2 solutions. 7 minus 2. 1 is my first solution. My second solution is minus 7 minus 2, that is negative 9, divided by 5. M is equal minus 9 over 5. Okay, entonces this equation has 2 solutions. Solution is 1, negative 9 over 5. Okay. Okay, this absolute value bar is extremely important. Okay, it means que it's a distance. All right. Entonces, what is the distance in which this expression, it doesn't matter if it's plus or minus, is equal to 7. 2 values. Normally, when the right hand side of the equation is positive number, we get 2 solutions. Si es 0, one solution, y si es negative, no solution. No, in this particular example, no. You follow me?
Yes.
Cool. Let's move on to the question 11. 11. 11 is inequality, and 12 is also inequality. So be careful, because 11 is less than, and 11 is greater than or equal to. Entonces now it's a little bit different. 11 is actual value 7x plus 8 less than 20. In this case, less than is one mnemonic divide to remember is like a close, not too far. So you remove the bar 7x plus 8, and this is in between 20 and minus 20. Because you know, see the expression is negative, it's the same distance, no? Now you convert my inequality using less than a new compound inequality que contain 1, 2, and 3 pieces. And you subtract 8. This is minus 28. This is 7x. This is cancel out. That was the intention. And this is 12. Finally, divided by 7, divided by 7, divided by 7. This is negative 4. Less than x, less than only 12 over 7. Okay, entonces they want que yo exprese the answer en interval notation. No leave it like that. This is perfect, but they want you write this like that. Parenthesis, negative 4, comma, 12 over 7. And close the parenthesis, no square bracket, because we have no equal sign. Guys, I need to go 1 second to the restroom and I'll right back immediately. I am back. Okay, does everyone follow me?
Yes.
Let's do number 12, but 12 is different. Why is different? Because it's greater than. Be careful. It's greater than, the properties difference. So basically, you convert our original problem, is absolute value 2 minus 3x, greater than or equal 10. You convert like that. You remove the bar, but you copy twice. And this is greater than or equal 10. So you look like the only thing I am doing in this step from this to this is remove the bar, but in this case, no, it's less than or equal minus 10. So you convert this statement in one compound inequality connecting by OR. You solve them separately. Let's do it. Minus 3x greater than or equal 10 minus 2. Minus 3x greater than or equal 8. And divided by negative 3. Remember, my goal is solve for x. X alone positive, of course, negative divided by negative is positive. And be very, very, very important. When you divide by negative, you have to reverse it. The inequality sign. That is minus a over 3. Okay, now I stop. This is one piece of solution. Second piece of solution is Working, and the second part is minus 3x less than or equal minus 10 minus 2. Minus 3x less than or equal minus 12. Divided by negative 3 one more time. And thus x alone is greater than or equal 4. Okay. However, they want interval notation to see more clear. In my opinion, remember the compound inequality solutions, we ending graphically to understand the connection between each part. Okay, so you are doing our famous all real number line. Infinity positive, infinity negative, 0 in the middle, 4 is 1, 2, 3, and 4, and 8 over 3, I put in my calculator, 8 divided by 3 is 2.6, repeated. Entonces es negative, pero es negative. Entonces negative 1, negative 2, negative 3, es in between, but this is 4. And this is negative 2.6. Negative 1, negative 2, negative 3, I suppose is here, approximately. Now I highlight. Highlight is less than. It's to the left. Stop here. And in that part, we have a square bracket to indicate us que incluye the value negative over 3. Now, and this is exactly the same. It's 1, 2, 3, 4. From 4 to positive infinity. 4 continue forever in that direction and bracket here. Now my final answer then is from negative infinity, comma, negative 8 over 3, bracket, union, bracket 4, comma infinity. Final answer. Any question? No? Are you strong in that part? Because I don't want, this is a classical mistake I saw every day. Some student, I don't care. I erase the bar and that's it. No, 0 for you, so you erase the bar, right? You need to respect the rule. Do you want que I summarize the information for this or you are clear?
Can you summarize it?
Absolutely. Absolutely. Okay, in the inequality, miss, suppose that you have actual value x. Doesn't matter the expression. Well, any expression. Any expression. Less than, it doesn't matter if it's less than or equal. This doesn't change. Suppose arbitrary number 10. This is equivalent. To write like that. Any one time in between 10 and negative 10. This expression equivalent 100% of this. And you convert this complicated problem, not complicated, but look like weird, to the easiest 3-part inequality. And you solve it simultaneously, and we expect one piece. The solution is one interval, not two. However, so you have absolute value, any expression greater than the same number, you decompose in 2 pieces. The first piece is any greater than 10, and the second piece is any less than negative 10, and you connect them by OR. In this moment, you have one compound inequality that consists in 2 inequality, and you ending graphically the solution. Super cool?
Yes.
Okay. Let's move on now to the question 13. Que es easy, in my opinion. However, I don't know why the student makes mistake for some reason the student don't understand very well. I want to emphasize this idea. Okay. Look, this is, I do not explain in the theoretical part this, but it's easy. This is determine the interval over the function is increasing, decreasing, and constant. Write your answer in interval notation. Cool. What mean increasing? Increasing is when the function is going up. Suppose this is going up, not necessarily linear, not necessarily linear. It's going up like a curve. You take 2 points to compare, and this is x2, and this is x1, and this is y1 corresponding with the x, and this is x2. In that picture, you suppose that always x2 is greater than x1. If this implies that y2 is greater than y1, it's because the function is increasing. But we have 3 possibilities. You have the possibility this is increasing function. Okay, suppose again x2 greater than x1, however, is going down, y2 is less than y1, so it's decreasing. Let me try to make a picture to understand decreasing. X, y, suppose decreasing something like that. This is x1 again, the first one, x2 the second. However, the function is going down, it's decreasing. Y2 is smaller than y1. This is super easy because you consider, look, suppose that this is the roller coaster car, travel onto the curve, so you go up, it's increasing. So you go down, it's decreasing. So you suppose a roller coaster car travel on the curve. So you're going up, it's increasing. So you're going down, it's decreasing. And so stay the same. See, you pick 2 different values of the x and you obtain the same value, it's constant. Okay? Because no increasing nor decreasing. So it's constant, stay the same. And sometimes happens, sometimes no. Ahora, the confusing part. The confusing part is that you express it. The answer, you express it, the answer of that problem using always x value. Never y value. No, no, no. Because the x value is the most important because it belongs to the domain. So inside the domain, I need to select in what portion I going up, decreasing. In what portion I going down, decreasing. In what portion you stay on the same height, constant. Okay? And you express your answer like a interval notation. They want. And the test always interval notation. So let's do it. It's easy. Look, let me show you. Okay, for example, the first graphic, I see clear that from 1 to 3 to 2, sorry, the function is increase because my roller coaster car travel in the direction. So you're right. 0, 2. Entonces now I don't know. So I put the parenthesis and I put the bracket. Well, this is confusing in my opinion. However, I believe can 2 know because 2 is the transition point. Okay, for example, a little bit before 2 is increasing, and a little bit after 2 is decreasing. So 2 is no, I have no idea what exactly is the behavior. Well, I have idea. This is the local max. It's another idea. It's a local max. It's the peak of the hill, no? But not included here. And here, yes. Bueno, I suppose que before 0 is no show here increasing the same behavior, but it doesn't matter. This is increasing. This is no idea. And from 4 to infinity, because this arrow indicates us that this continues forever in that direction. My roller coaster car also go up. Entonces es union 4, paréntesis 4, no include 4, comma infinity. Okay, entonces this interval and this interval cájela en, let me show you en red color. Wait a second. That part and that part is increasing. Increasing red color. In the test, be careful. Sometimes it's giving you y value. Okay, this is 10. No, not 10. 1, 2, 3, 4, 5, 6. This is 6. Entonces the student say, well, no, professor, the function is increasing from 0 to 6. No, no, never y value, always x value. Okay, it's increasing from 0 to 2. Include 0, no include 2. And for 4, no include 4 to infinity. This is the answer que I want. Domain, no y value. Cool? Now, what about decreasing? Decreasing is obviously from 2 to 3. Let me select another color. Maybe green. From 2 to 3 is decreasing. Of course, again happen, no include 2 and no include 3. Because in 3 is a transitional point, this is decreasing, and now from 3 to 4 is constant. So now I have no idea. I have the idea in this, but I have no idea what the behavior in 3. Entonces es paréntesis 2, comma 3, no include both endpoints, is decreasing. And finally, constant is using another color. Be blue es in between 3 and 4. Es obvio que no incluye 4 and no incluye 3. Entonces, paréntesis 3,4 is constant function. This idea is clear or confused?
Clear.
Clear. Okay, let's move on to the second curve, que is a little bit more confusing because it's oscillating. It's going up, it's going down, it's going up, it's going down, it's going up. For example, I see clear que from 0 to 2 is decreasing. It's also decreasing from 3 to 4, and it's also decreasing from 5 to infinity. Because this line, this arrow indicate us it is continuous forever in that direction. So you can write increasing is bracket 0, comma 2 parenthesis, union, 3,4, union, let me erase that part, union, parenthesis 5, comma infinity. And not include inside again the transitional point. It's not included. However, the increasing is that part, increasing and increasing. Okay, so increasing is from increasing. Sorry, this was, I make a mistake. That was decreasing, no?
Yes.
I using the correct color, but not the correct word. This is another problem. And increasing now is, okay, 2,3 and 4,5. And never constant. Do you see a never constant? Constant is when it's completely flat, like that. The y value stay the same in the entire interval, and it never happened. It's going down, it's going up, it's going down, it's going up, it's going down, and that's it. It's easier, eh? Or be careful with it, you write the answer. I need the answer, number 1, interval notation, and number 2, using x value. Okay? Any question, guy? Let's move on to the second page of the review. Let me see. What the hell? Suppose que hay transfer, ¿no? Let me see. Wow. Bueno, no, okay. Entonces, no image is PDF, maybe. Let me see, PDF, yeah. Document, device, desktop, all, MATLAB, okay, there you go. Number 2. Boom. Insert. Okay. Number 2 is piecewise function. So one piecewise function is given like that. I need to interpretate this piecewise function, and you evaluate this piecewise function in a specific way. So let's do it. This is my famous again area number. Help me to understand this piecewise function. Okay, and this is infinity positive, and this is infinity negative. And this is 0, 0, 0 in the middle. However, we have 2 transition points. In -2, something happened. Look. In +3, something happened. +3 is 1, 2, 3. Let me use in different color. For example, from -infinity to no include to no include no. We have as valid this expression. -3x plus 2 is valid this expression. And between -2 and +3 is, of course, include -2 bracket, but no include 3. Is we need to select this expression. And finally, for another color, maybe green, from 3 to infinity, of course, include bracket 3, and this continue forever, is this expression gets just 4. It's a constant function. Remember, guys, this is a y value. This is the y value. Or another way is f of x. Okay, this f of x. Okay, selecting or this piece, or this piece, or this piece. Depending on the value I want to evaluate. And you need to evaluate several. F evaluate -2. Be careful, because -2 is weird, it's tricky. Because you need to identify your -2 belong to the blue part or to the red part. What do you think? Belong to the green, or belong to the red, or belong to the blue? What do you think?
To the red.
To the red, because what is the glue that give me that information? This equal. Okay, so you select this expression. This is a process, selection, this expression, and I copy, just copy x squared plus 1, and you evaluate at x equal -2. Be careful with the sign. Is parenthesis -2 squared plus 1. And -2 squared is 4 plus 1 is 5. Boom. Final answer in the first one. Fine. Let's do it. 0. 0 belong to what? To the red, to the blue, or to the green?
The red.
The red. And you select one more time this expression. Edward. And you will add 0. So you get 0 squared, 0 plus 1 is 1. Final answer. Add 3 now. Add 3 belong. Add 3 belong to the green, to the red, or to the blue. Positive 3. To the green. So you take to the green, you select this expression. Okay, by the way, this expression do not depending of x. So you don't need to replace this 3. Only is using, is utilized to select the piece, but no contain x, entonces just constant function que es 4. Boom. Now this is 4, no? 4. Let's use negative 3 now. Negative 3 is blue, red, green. Come on, help me. Negative 3 is here.
Blue.
Blue, very well. Use selection. The expression que corresponde with this interval, que is minus 3x plus 2. And you put this special symbol, this is convenience notation, such that x is equal to minus 3. Plugging in, minus 3 times minus 3, you replace the x for minus 3 plus 2. Obviously, this is 9 plus 2, 11, no? Positive 9 plus 2, 11. 11, 11, 11. And 5. And 5 is here, no? Positive 5 is green. It's 4 again, for the same reason. And negative 4, we're using again here the blue. Okay, is 5, 4, and negative 4 is minus 3x plus 2. Evaluate at x equal negative 4 is negative 3 times negative 4 plus 2 is 14, no? Because it's positive 12 plus 2, 14. Boom. Final answer. Easy, easy, or complicated, complicated? Tell me. How do you feel in this? Come on, this is a moment review. So you feel okay, we could keep going. So you don't, you have any question, any doubt, let me know now. This is the moment to say, Professor, what is the reason that you are doing it that way? No? Okay, let's move on to the 15, it's another piecewise function, but this is different because it's graphically. Because graphically, I want to do by hand, and also we are doing using decimals, because actually in your test you are doing with the way you consider better for you. Okay. Let me try to do by hand. I take my piece of paper, my pen, and my rule. Okay, I have my graphic paper. And I take that the pieces is y equal minus 3 plus x. This is the graph of the first piece. Look at that. For a moment, I don't care too much this condition after I fix this. Okay, entonces now this is easy. It's a line, it's a linear function. Entonces y is equal x minus 3. Es obvio que you compare with the y equal mx plus b. And b is negative 3. And m is positive 1. Entonces, negative 3 represent the y in a set. Y in a set is negative 2, negative 3 here. Negative 3. And as low as 1. Therefore, from this point, let me make it soon to see more clear, is The slow one is one upward because it's positive and one here. I obtain the second point and to say I am ready to connecting this point. Is so far the only thing we are doing is this is 45 degree. 45 degree. Okay, the graph of the first piece. Okay, I want to do in Blackboard. Cool. Now, the second piece. The second piece is 12 constant. Look at that. Is y equals 4. Okay, this is f of x, que es equivalent to say y. No? Y equals 4 represent horizontal line. Horizontal line passing through the point 4, positive 4, and slope 0. You take my rule, I put 0 degree. 0 degree here, but 4. And 4. Everyone follow me so far? So to do the graph by hand of the piecewise function, I did well. I did know well. Let me fix it a little bit. Okay. Boom. S4. Try 3. Rule again. No. A little bit up. Much better. This is the line y equal 4, no? Horizontal line. Cool. So the only thing we are doing so far is doing the graph of the two pieces of the piecewise function, but separately. Now the super important moment. What is the transition? Oh, the transition is in 1. So 1 represents for us a vertical line at x equal 1. This line is split the plane into semi-plane. So now I take the rule. I put 90 degree because it's vertical line. Passing through 1. Exactly. Passing through 1. I recommend doing like a dotted line because this is just auxiliary line can help me to understand my piecewise function. So I am almost ready. To do the graph of the piecewise function. This is always only auxiliary thing we are doing to finish my graph. I come back to the my piecewise function. Look at that. My piecewise function say. Erase that part. Is from less than 1. Obviously, less than 1 is this semi-plane. That part. Okay, it's valid. This expression is this line. Therefore, by using another color, maybe red, a little bit bold, using the rule again, 45 degree, 45 degree. I am doing the graph of this piece of line que is coming from negative infinity and stop here. No, here in 1. I have no idea what's going on here. So this point is important. I don't know if it's closed or open. And we have a jump discontinuous. So I'm moving. jump to another line. Okay, another line is 0 horizontal, like that, and keep going in this direction. Keep going in this direction, keep going in this direction. I don't know what happened here, but this point is extremely important. Entonces now we have two kinds of point. This is open, and open is when it's not equal, and this is close when it's equal. Again, I need to go to the restroom. I take the medicine. Okay, give me go to the restroom frequently. Don't worry, I continue. It's too fast. Here again. Okay, entonces close. Who is close and who is open? Well, okay, look at that. I see que no equal sign here represent open. That's it. And equal sign here in one is close. So you put close here, and that's it. So what is my graph, Professor? Because I don't understand anything. Well, my graph is, okay, I delete everything. Not everything, but delete almost everything except the line, the part I did in record. This is the graph of the piecewise function. Obviously, that function is discontinuous. Discontinuous means that we cannot do the graph without listing the pencil from the paper, no? That we have John discontinuous here. Moving the pencil, boom, I continue the second part. Do you understand this or no?
Yes.
Okay. Do you want I show you how we are doing in Desmos? Exactly the same job in Desmos? Oh no? Yes, Edward is a yes. Or you prefer optional, guys? So you like paper, like papers. You like what's that? This is the Greenview. Greenview, I see my students. Okay, entonces now let me try Desmos. Desmos. Okay. Let me share the screen. Switching Desmos calculator. Do you see now Desmos? Yes or no?
No.
Yes. Got it? Now my function is
I don't see it, Professor.
You see what? You see Desmos? Yes or no?
Oh, we just see you and like a green screen behind you.
Me. Let me try again. Maybe I did stop sharing, maybe. Oh yes, you're right. And now calculator. Now? Okay or no? Now? Now?
No, nothing changed.
Nothing changed. You need to be patient. You see the whiteboard. Okay. switching.
No, I don't see it.
You see now? We're doing context view. Context view. So you need to go to the context because some students change the view and create another background. No. You don't touch anything. Don't touch anything. You screw up everything. No, don't touch view. I put always grid view. Grid view is the view can see your name and your face. You activate your camera. But don't touch this. Okay? Now you see Desmo or no? Maybe leave or come back.
I see it now.
You see now? So you need to.
Yeah, I
Sometimes
can see it.
it's not instantaneously the transfer because depending the speed of the your internet something. Okay, entonces I remember something. I remember que es y equal 3 minus x. You see esa line? However, we have a restriction. No, it's a real number. No. You put it like the curly bracket like that using the keyboard. No, don't do that.
Professor,
No.
you wrote the equation wrong.
Yes. Okay. Well, let me see. I write the equation wrong. The checking is n minus 3 plus x, no? Yes, you're right.
Yes.
Yeah, you're right. Thank you. It's minus 3. Okay, minus 3 plus x. Minus 3. Wow, it's logical. It's a positive slope. And you put the restriction, okay, the restriction, I remember, you correct me say I make a mistake, is x less than, using the keyboard, that's what I like so much, less than 1. Oh, and so you see one piece of the piece que you need. And the second piece, and the piecewise function is y equal 4. But the restriction is, open the curly bracket like that, and you put x such that x is greater than or equal 1. Boom. Let me use in the same color because obviously it's the same function. It's piecewise function, 2 pieces. However, the most important part now, so you leave it like that, no, 0 point for you. The points. The point are, look, in decimals, you put open parentheses, and you copy 1,4. 1,4 is this point. But no green, I don't like green. I like red. Of course, I like the close point like that. If we have another point, let me put a label of the identification. And the second point separately is the point 1, negative 2. How do you know? Look in the picture. It's parentheses 1, negative 2. And again, we have a label. We have the same color because it's the same function. But this is a hole. This is the open. And this is the beautiful thing that you need to send me attachment for your test. Export. Bam. This is the graph. Okay? But you accommodate the zoom, you accommodate the size. I don't like this. I like this. Well, either way, this is aesthetic part. It's up to you. Any question? What part you prefer, Desmo or by piece of paper? By hand or Desmos?
I prefer by hand.
Excellent. I respect. Free country. We are living in the free country. Okay. I come back again. I try to come back. the whiteboard one more time. Whiteboard. Let me know if we come back or no. We come back.
Yes.
Let me delete that part. Let me erase everything I don't need for the next questions. Okay, now this question 16. It's easy. It's about transformations. Is you have a function que es f of x. Equal minus x squared plus 4. And they want que you do the graph using transformation, do the graph. And also find y-intercept and x-intercept. Let's do it. I realize immediately that my function is given in the test, equation 16, belong to the family of the quadratic function. The quadratic function, the basic quadratic function is the parabola, like that. Okay, this is the function x squared without transformation. Now I see two transformations. One transformation you can see, this minus, a reflection about x-axis. Basically, when you multiply by -1, my parabola is going down. It's going down like that. This is negative x squared. CS plus 4 is vertical shift 4 units upward. This is the y-axis. Now my new graph after the two transformations. This is transformation 1. By the way, this was reflection. Reflection about x-axis. We have another transformation que es vertical shift over 5 units. 5 no 4. Therefore, is this point gets 0, 0. Normally, now it's 0,4. Okay, cool. Now, this is my new graph. Separable also. It's up and down. And by the way, the x-intercept, the y-intercept is that point is 0,4. And the y-intercept, I have no idea. I found out using the formulas. So far, everyone follow me with the graphic part and transformations?
Yes.
Okay. Now, what is the formula for finding y-intercept? It's easy. Using function notation. You evaluate at 0. F is 0. So in our specific problem, f in 0 is minus 0 squared plus 4. 0 squared is 0. 0 have no sign. The answer is 4. Then the point is 0,4. This 0 was the x value that I plugged in, and 4 is the y value that I obtained after the substitution. I'm going to find the x-intercept, is the point in which the curve crossed the x-axis. The super fantastic mnemonic device to remember the formula is you take f of x and you put 0, put 0 and y. Remember, y is equal to f of x. Find the x-intercept, you put 0 here. Find the y-intercept, you put 0 here. And leaving the x here and solve this equation. Normally this equation, solve it. Okay, so my equation is minus x squared plus 4 equal to 0. Wow, it's easy, it's a quadratic equation, ¿no? Entonces, minus x squared is equal to minus 4 divided by -1 both sides. X is equal to 4, x squared, sorry, square root both sides. x is equal plus or minus 2. Conclusion. My x in the set is the point 2, 0 and minus 2, 0. You have two solutions, no? Plus and minus x value, and the y value, no. Y value is 0 at the beginning, I assume. At the beginning, I suppose. 0. Here, this 0 gets this 0. So you plot this point is 2, 0, and this point is minus 2, 0. Boom. Final answer. Graphic using transformation plus x in the set and y in the set. Any question? The formulas. This is a fantastic formula that we're using from now every day for finding y in a set and x in a set. Cool?
Cool.
Excellent.
Yes.
Number 17 is very similar. It's very similar. It's graphic again using transformation and find the y in a set and x in a set. I suppose that in this test is important that part. Okay, but this is a little bit different. Is g is the name of the function. Is equal square root minus x plus 2. Wow, what the hell? I suppose that we have transformation. I suppose using my intuition that we have a reflection here. But this reflection is different. It's a reflection about y-axis. How do you know? Because it's inside. So you need to understand that this reflection, you put a minus outside, is different to this reflection. You put a minus inside the parentheses. And this reflection is about x, similar to the thing we were doing before. And this is about y. Okay. Entonces, bueno, no, pero I don't understand. I don't see any parenthesis here. Bueno, I suppose that the radical represent a grouping symbol, no? So you see the minus here outside. Entonces this. But in this case, no, it's inside the, you know, no parenthesis, pero radical, absolute value, etc. is considered like a grouping symbol. However, this is a scenario in which it's not totally clear to see. So now I need to manipulate a little bit the expression inside to see more clear. So I propose you factor out -1. This -1 I put outside again. So I open new parenthesis. I put x minus 2. Let me see. Let me try to understand that this is equivalent to this 100%. If you distribute this -1 here, we have minus x plus 2. Wow, fantastic. It's equivalent. However, at least for me, it's easy to see that we have reflection and we have a horizontal shift 2 units, but to the right. Remember, when it's negative, it's to the right. When it's positive, it's to the left. So I know very well that function g belongs to the family of the square root function. Yeah, I need to know by memory that the graph of the square root function look like that. This is y equal square root of x. This is the original, the basic, without transformation. By the way, this point is 0, 0. This point would be 1, 1, because the square root 1 is 1. No? And another important point is 2, 3, 4, 2, because the square root 4 is 2. So this point is the point 4, 2. And we can get more. You want 9, 3, 16,4. You know, it's increasing function, but go a little bit slow, not too fast. This is a square root function. Now, definitely, we apply the reflection first. According to the order of operation, reflection first. Bueno, si es reflection, entonces the only thing you should do is reflecting, pero in that direction. Our thing is like that. This is the x-axis and the negative part, you know, this is 0, this is -1, -1, no? And this is -4, 2, 3, 4, -4, 2. Okay, basically, the only thing we are doing is this. Y equal square root -x, this part. Okay? This is my transformation number 1. What's the name? The name is reflection. Reflection about y-axis. Okay, I feel no, I need to do another horizontal shift. It's 2 unit to the right. Si it's 2 units to the right, any point by point is moving to. This 0. Now it's not 0, it's in 2. This is a point 2, 0. This point is 1, 1, -1, 1. Now would be when you transform it. See, it's 2 units to the right. You affect the x component and the y component, no, stay the same. Entonces, 1, but this is -2, -1, +2. The positive one. At this point is become 1, 1. This point, transform it as this point, transform it as this point, and that point is the point -4, 2. Okay, it's transformed now. -4, 2 is transformed to another point is 2, because the y doesn't affect, because the horizontal shift, no vertical shift. And you adding 2 units in the second component is a -4. -4 plus 2 is -2. Okay, entonces -1, -2 is here. -2, 4. The 1 is 2, 3, and 4. Okay, and this is our this graphic. It represents the original square root minus second root. What is the confusing part, guys? Everything is clear or confused? Do you understand where I come from this point?
Yes.
Yes.
Entonces I forgot to say here that we have another transformation. What is the name of this new transformation? Well, it's horizontal shift, 2 units to the right. And to the right means, okay, point by point, you move in 2 units and you adding, and the x value +2, +2, +2. And the y value, no, the y value stay the same. Okay, my graph is not too good. If you want, do one can do in decimal. No, porque en decimal, that is the complication that you don't see. Just, either way, by hand or decimals. Either way. I accept any way correct and smart, I accept. So using your imagination, present the final answer in the test. Let me say something. When you send me back the answer, remember the due date is September 14, no? They say before, no? Say 14. So tomorrow, no. Today is Monday, Wednesday. Wednesday, you have Wednesday to midnight. Send me. To say Tuesday, Thursday, I will grade this test, okay? Cool. No problema. Transformation is good.
Yeah.
Oh, I forgot the most important part. The most important part is the y-intercept and the x-intercept of this function. Of the, not the rich, the given. I need to investigate in this expression both x-intercept and y-intercept. Remember, the only thing I need to memorize for finding y-intercept, you create G, evaluate 0. Entonces, square root minus 0 plus 2. 0 have no sign, 0 is 0, plus 2 is radical 2. And radical 2, you know, is irrational number. At this point, I suppose, is a point 0, radical 2. And decimal is approximately 1.41. Put in the calculator. You don't need to memorize this. And G and X, to find the x-intercept, you take the original function and you enforce it to be 0. Entonces la que es radical minus x plus 2 equals 0. And you have in front of radical equation, square both sides in order to eliminate, destroy the radical. Minus x plus 2 equals 0. We continue here. Minus x is equal to minus 2 divided by negative 1 both sides. X is 2. And the point would be the point 2, 0, exactly is this point. No surprise. This is x-intercept, and this is the y-intercept. Any question? Good?
Good.
Now my goal is to finish today the review, no? I suppose we can do that. We finish, we gotta go. Okay, number 18 is easy. One piecewise function is given, but not given algebraically. No, it's given graphically. And you need to evaluate looking in the graph. And be careful where the points are close. Close mean when you see one point gets close, it's defined. When you see open, it's undefined. It's the symbolic way to indicate that. So f and 4. Okay, 4. So f of x equal y. So it's giving one value of the x domain you can find on the x-axis, and you try to go to the curve, and when they touch the curve, bang, you go to the y-axis and determine the value of the y. This is the goal of this. And you need to know if you go upward or downward, depending the graph, you know. For example, 4 here, this 4. I go touch here, and the value is 5. You see? You see?
Yes.
Negative 2 here. So now, in the test, I don't want you using your common sense and imagination. This is not clear declaration of this. You assume the answer that you consider more properly, more correctly. This is a line, I guess so, and this is negative 2. Because this is negative 1, it's obvious that this is negative 2, or negative 3, negative 3. So the answer is negative 2. Do you see or no?
Yes.
And 2 positive. 2 positive is this guy. When I go to the curve, I see close and open. I take the close, que es when it's defined, is 4. And 0 is 0,0. That's it. And negative 1 is obvious que es, wait, be careful. Because we have here open and close. So in what direction I go? I go upward or downward? It's obvious que upward. I go to the defined, not undefined. Undefined is bad guy. So the answer is 1. And negative 4, it's exactly the same. Negative 4 is negative 4. To extend in this, negative 4. And negative 5 and negative 5. It's the same value, but negative. And positive 5, F5. And positive 6, F5, because it's completely outside. But remember, in this kind of problem, you need to use imagination. And extra ball, extending the graph in both directions, but using the logical idea. This is 5 and 5. 7 and 8, you don't see, but you can use it get the function, or you can see that the function is constant. Forever. This arrow indicates it continue forever constant. And CSF in 1000 is also 5. Clear?
Yes.
Excellent. So be careful. What is the complicated part or the confusing or the tricky? The tricky is you go to the value that you have inside the parenthesis of the function notation. And this is my x value. I go to the curve, and when you touch, but to touch, maybe you move it upward or downward, depending, no? And see, we have no function to say you extending extra ball after the interval is not given. It's not clear, but you assume using your common sense. Make sense or no?
Yes.
Cool.
Yes.
Let's move it on the last document. Is this? Cool. Okay, there you go. It's a question 19, no? Suppose que, well, okay. In this question, the only thing I need is determine domain and range, look in the graph. No algebra, no nothing, only look in the graph. And remember, what's the idea? You take arbitrary point on the curve, bam, 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 and you projecting onto the x-axis to determine domain, and you projecting onto the y-axis to determine domain. Suppose, in this case, I complicate a little bit because we have close point, open point, and gap. Because in between 2 and 3, we have no function. It's undefined, right? And maybe in the test, no, it's easier. Entonces, no gap, no hole, no close, entonces it's easy. So the supposition is all real number, but in this case, domain, let me try domain first. Domain is from negative infinity to this. Because the projection, this point, onto the x-axis, give me their value. This is clear or no? And in 2, no. In 2 is parentheses, because I see here open. However, in 3, no. In 3 bracket. However, in between 2 and 3, we have a gap. No value, no domain. And this continues forever. So now they want, can you write the answer in interval notation? The domain, this function is given graphically, is from negative infinity, comma, 2 parentheses, no, 2 no, union, bracket 3, comma infinity. Cool? Now let's move to the range. It's the same idea, but using y value. The y value, you're projecting the function onto the y value. Yeah, I can see that we have y value here onto this. Because in 4, 5, 6, no y, no. However, I can see that here, don't touch 3 because in 3 we have a hole undefined, and it's continued forever. I don't care too much the gap, because in that part overlap, the 2 and 3 overlap, we have defined in this portion. We have not defined, but it's complementary with this, no? So what is the answer? The answer is from negative infinity, comma 3, y in 3 is parenthesis, no? No bracket. I put the bracket. Hey, I'm crazy. No bracket because this is open, no? Do you understand this or no?
Yes.
Question 20, that's 190. It's easy because it's a combination of the function. The function is given, and you combine using division. So you have two answers. Be careful. The first answer is new expression. That's easy.
Professor, for number 19, the range is just negative infinity to 3.
Yeah.
It wouldn't. It wouldn't be negative infinity to 3 union bracket 2 comma infinity.
You say guess from
For the
negative to 3 union what?
Bracket 2 comma infinity.
No, because we have no function in that part. So our y value of the function ending here. Look, we have function. Okay, let's projecting this. Projection in this direction. You projection in this direction, you go to the minus infinity is clear, and 2 is okay, and 3 no. So es paréntesis. Pero en 4, 5, 6, no, we have no. So no that part. Make sense or no?
Yes, it makes sense.
So the thing I tried to explain in the 20 question was, it's easy, but you need to express two answer. The expression first and domain second. Okay, so you omit 1, 0 in this question. Okay, so now I have division. Well, division is piece, okay. Division is this symbolic way. It's equivalent to say you divide f of x divided by g of x. Again, the story. What should I do? Well, you copy, and that's it. 7x squared minus 6x divided by x squared minus 24. X plus 24. 24, not 2. Shh. I'm crazy. 2x plus 24. Done. This is my first answer expression. We can do something if you want, but not necessary. You leave it like that, 100.5. Now, the second part is state is domain. And you need to remember when you have fraction like that, I know that the restriction is one of the domain assume it's all real number except the restriction, and the restriction in this specific case is when the denominator is 0. That you need to investigate in order to express one answer that you see all real number. No. You need to investigate what is the bad guy, value can create 0 in the denominator. But this is easy because it's a quadratic equation, no? And let's solve in the quadratic equation and end the story. Okay, so now I propose you, I suppose that by factorization no good. I propose you BC, quadratic formula. A is 1, B is negative 2, C is 24. Says minus 2 is 2 positive. Remember the formula have minus B, double minus become positive, plus or minus. Square root negative 2 squared. Minus 4 multiplication by A gets 1. Multiplication by C gets 24. Divided by 2 times. We focus 100% in the expression inside the radical. Expression inside the radical is a 4. And this is minus something, and this is 24 times 4, I suppose 96. Let me check it with the calculator. 24 times 4, yeah, 96. I'm subtracting. It's minus 92. Oh, entonces when you compute the square root of the negative number, it's obvious that it's complex. Imaginary specifically, but when you put together when the rest is complex. And entonces now the supposition, remember, you don't know anything at the beginning, However, you try to investigate. You assume that the domain always is all real number, negative infinity to positive infinity, except the restriction. And to say I dedicate time to investigate the restriction, the super fantastic conclusion was, no. The restriction is a complex completely outside the real number line. Therefore, there is no important. It's completely alien living in another planet. So I don't care. And our Earth planet is all real number, and the answer is domain. So this supposition was good. Domain is all real. And this is a specific example, no? Another no. You get solution, real solution. So you delete this, so you remove this bad guy in the domain. You follow me? Do you understand very well this or no? Sure. Guy, review we are doing. I need to feel good that you understand. No? So you don't understand, repeat several times until you understand. Clear or no?
Clear.
Clear? Clear. This is question 20, no? Now 21. 21 is easy. 21, the student frequently make a mistake in 21 because they believe this symbol, so in 21 is given the two functions. It's a combination of the function. So we have two functions, the function f is 4x squared plus x, semicolon, the function g is x plus 3, easy, linear, and I want to find f composition g of x, and also g composition f. So in different order, and you know very, very well, when you change the order of the composition, you get completely different function. But the interpretation for the composition, this zero, this symbolic way, zero, look like zero, but actually it's not zero. This composition is no multiplication. No, you multiply this and this, wrong. It's composition. It's you have two functions, and the function g go inside the function f. Likewise here, it's different. It's g and f go inside this. Okay, so what is the interpretation? Well, the interpretation is I take this and replace here and here. Okay, so now we have 4 x plus 3, no x anymore, x plus 3 is squared, plus x plus 3. You replace the x and f for the entire g, que is x plus 3. And leave it like that? No. You manipulate a little bit, put it in an elegant way. Of course, I FOIL this. This is 4 times x squared plus 2 plus 2, no, plus 6x plus 9 plus x plus 3. I remove that parenthesis. 4x squared plus 24x 36 plus x plus 3. 4x squared plus 25, 24 and x combined like that we are doing 39. Boom. And this is expression that corresponds with f composition g of x. Boom. Finals. End the story. Okay. I'm talking about the domain. No. So no. No problem with the domain. By the way, the domain is all real number because we are talking about polynomial. Any polynomial, domain is all real number, no restriction. This is all real number, also a linear function. So the combination both, I suppose. But no. The question don't say anything about them. However, say about the opposite direction, no, is I need to split the paper into pieces. I need to compute now G composition F. It's a little bit different. I'm using another color. Green is good. And now you take this guy inside this. It's easy because it's inside only one x. So basically x, replace x for this is 4x squared plus x. If you want, you put the parentheses, but not necessary in this case, plotter. Is 4x squared plus x. Say G composition F. Final answer. And number 21. How do you feel? I suppose get 100 points in this test, yes or no? Take advantage, guys. This is easy test. The second, no. The third is horrible. Number 4 is the most complicated, in my opinion. And the last one is not too much. Let's do it. Last question. Last question. I never explained before. I want to explain now. It's easy. Is one easy problem about function notation. And the name of this is the famous different quotients. Let me explain what is that. Different quotients. Different quotient is application que you see in calculus. When you take calculus, sum. Entonces en cálculo you see the famous different quotient, is the formula que somehow involve function notation. Different quotient is, I want to copy the formula now. You subtracting in the numerator the function is given in the problem x plus h. Subtracting the original f of x and divided by h. This is the formula. And let's do it step by step. Step 1. Find the first part is this. I am doing that part in the formula. Oh, it's easy because you take the original function gets given. In this example is this is x squared minus x plus 6, and you replace x for x plus h. Square minus 5 times x plus h plus 6. You follow me? Leave it like that? No. No. Expand. It's doing. Expand in elegant way. You put x squared plus 2xh plus h squared. Distribute it now. 5x minus 5h. 5h plus 6. Cool. I finished the first part. The green part in the formula. Let's do it at step 2. Step 2 is easy. It's subtracting the original. So basically it's something like that. Look. Subtracting the original. This one. Now you take this answer and subtracting the original. Because I want to recopy x squared plus 2xh plus h squared minus 5x minus 5h plus 6 minus the original. What is the original? The original is x squared minus 5x plus 6. This minus affect everything. If you want to subtracting. Okay, complete. I copy But be careful, this minus affect everything, opposite side. So in this crucial moment, a lot of people is canceled. Look, let me show you. This guy is canceled with this. This guy is canceled with that. And it's canceled with that. And stay alive. Two xh plus h squared minus 5h. Boom. Now what about the final step? Step 3 is division by what? By h. Step 3 is you take this expression, okay, we computed before, and divide it by h. This is my famous difference of quotient. Look at that. Last step is divided by h. Last stage divided by h. But divided by h is super easy because actually it's division polynomial divided by monomial. When you divide by monomial, you divide one by one separate if you want. This is square. So basically, this h is cancelled. It's taking 2x plus 1h because h squared divided by h minus 5. Boom. And this is the final answer. Okay, I want to investigate in calculus. Different quotient for one thing I don't want to explain now. Okay. Do you understand or no?
Yes.
Do you need another example of this or no? Do you need another example of the different quotient or no? We finish. What do you think? It's better. How do you feel? How do you feel?
I'm good with.
Okay, everyone? Show me your hand. Raise your hand, the people who feel good. Joshua, humor is good. Gladys, Chelsea. Okay, a lot of people who say, no, come on, guys. Working. Remember, September 14, we start new chapter. Okay, yay. Great. Next day, 15. Okay, bye. Have a nice day.
Wait, how are we gonna do the other tests? Like there's 2 tests, right?
No, okay. We have the classical test on paper and we got the classical test online. Okay, and the corresponding homework, que es extra credit. Remember, repetition again. Every chapter contains 2 tests. Online, Alex. On paper, I send in your corresponding moment. No? En Alex es multiple choice, you know. You not necessarily multiple choice. You compute and put. It's online. It's any problem you have when the Alex grade, because sometimes Alex grade wrong. Because remember, Alex is a robot, no? You communicate with me, I fix it. So you have the right answer. 2 tests, Alex test and paper test. In the paper, you show me your word in detail, convert to the format, electronic format, maybe PDF or maybe picture. It doesn't matter the way you prefer, and send me back by email. These are 2 tests for each chapter, and we have 5 chapters. We have 2 tests, 10 tests total. Entonces, how we compute the overall grade is the average. And remember, the extra grade is cumulative. You have 10 points extra, 10 points extra, 10 points extra. Es supposed que it's a little, pero no, it's not too little. And the 5 extra points in the subscription in my YouTube channel is not negligible, I suppose, no? And sometimes decide the boundary between the B and A, the final grade. Okay, guys, bye-bye. Soon I will send the video, okay?
And will you send the test on the 14th?
14.
Yeah, will you send the test on Wednesday, an email?
Sí. 14. The test I sent in this. So you don't have the test. I sent today and the last day by this email. Check the email. Si you don't see, you communicate with me by email. I send specific for you a copy of this. Right?
Okay, thank you.
No problem. Okay, guys.
And then we
Bye-bye.
email you a picture.
Give me or PDF, Mister. Or PDF.
Okay.
So okay. The idea is in my mind. No, maybe you create another more smart way. You print out the document.
Oh, okay.
Wait. You solving in your own piece of paper. Ready. You scan using a scanner. Some students have a scanner in your smartphone. Convert to PDF, and you attach in my email. Good.
And Professor, do we also send you the work from the multiple choice?
Please.
Okay, all in the same email?
No. In Alex, no. In Alex, you don't send me now. You send me only the test on paper for the solution. In Alex, you working online, I checking online. That's it. No document. Don't waste the time to copy. No. Don't waste the ink. No. Online. Alex. And the on paper is this. I sent today. Good.
Thank you, Professor.
Bye now.